Hello there, and welcome to the Eppendorf Lab Channel, your home for webinars and live demos presented by life science experts at Eppendorf. My name is Simon Plate, and I'm the Global Marketing Manager for Pipettes and Dispensers here at Eppendorf. We're streaming live today from our headquarters in Germany, and our webinar today is the second episode of our Pipetting Masterclass series, where we cover different facets of liquid handling, from manual pipetting to lab automation. As part of the Pipetting Masterclass, we will hold a total of 7 webinars until February 23. You can always rewatch all episodes after the live stream in the past events section here in the Eppendorf Lab Channel. Today, we want to show you a few tips to improve your pipetting technique. The title of our webinar today is Proper Pipetting with Air Cushion Pipettes. And in the next 30 to 40 minutes, you'll learn what to keep in mind when pipetting with air cushion pipettes, how to avoid typical pitfalls and increase your pipetting performance in the lab, and why pipettes and pipette tips need to be considered as a liquid handling system. Now I'm happy to welcome today's pipetting expert and presenter, Dr. Nadine Melies. Nadine holds a PhD in biology from the Institute of Human Genetics in Göttingen, Germany, where she gathered a lot of experience working with cell cultures. She joined Eppendorf in 2016 and now works as application specialist in our headquarters, where she's responsible for general liquid handling system trainings and applicative support. Hi, Nadine. Great to have you here again.
Thanks, Simon, for the kind introduction, and also welcome from my side, and thank you for joining this webinar today.
Yeah, we're excited. Before Nadine starts to share her tips, though, I'd like to quickly highlight the features of this live stream on the Eppendorf Lab Channel. If you scroll down, you'll see a few links to further educational content from us. And Nadine will mention all of them in their presentation, so you will always see what she's referring to. If you take a look to the right of your screen, you see a chat window, which you can use to send us your comments or questions. After Nadine's presentation, we will have a short questions and answers to address selected questions. Yeah, now that this is clarified, I'd like to hand over to Nadine.
Yeah, thanks. So let's take a closer look at proper pipetting with air cushion pipettes. And for all of us who work in the lab, working with pipettes is part of our daily routine. Pipetting has become something very normal and very usual that we don't really think about it anymore, which is on the one hand quite good. But yeah, when we want to transfer liquids, we just pick it up, attach the pipette tip, and there we go. But sometimes it's quite good to remind ourselves and pay some attention to certain aspects of pipetting, because even if pipetting seems very simple, it bears many error sources that in the end influences the reproducibility of our data. So, and unfortunately, this is quite often negative. Good pipetting starts with the choice of pipette tip, and the way we as users operate the pipette and the type of liquid we use it for also plays a major role, as well as the environment in which we pipette. So we have already addressed how we choose the most suitable liquid handling tool for the application in the webinar that kicked off this series. The webinar, as Simon already mentioned, is also available on the Lab channel as a recording for those who have missed it and would like to watch it. It is important to know that in principle, 2 different operating principles are used. While air cushion pipettes are used for aqueous solution and common buffers, positive displacement systems should be used when pipetting difficult liquids that differ from water in their physical properties. And especially the choice of pipette tip as well as operation of air cushion pipettes can lead to mistakes. And these are the issues we will deal with in more detail today. So we will start by taking another brief look at the air cushion principle and clarify when to use the so-called forward and reverse pipetting. Then we will look in detail at the pipetting technique with air cushion pipettes. So what should you look for when aspirating and dispensing liquids? Which pipette tip should be chosen and why? And finally, we will summarize all the important points and have some time for our Q&A. So a good pipetting technique is key to achieve reproducible data. So in fact, the way we pipette has the highest impact on experimental results when looking at the different techniques. It is one thing to use the right tool, but it's another to use it correctly. And as mentioned already, this is most important when we use air cushion pipettes for our experiments. Therefore, let's take another brief look at this operating principle. We can see it here on the right side. And then in an air cushion pipette, the piston is separated from the liquid sample by a small air cushion And this air cushion works like a spring during aspiration and dispensing of the liquid. Temperature or humidity changes, as well as other physical properties of liquids, can affect the performance of these instruments. When pipetting liquids with increased vapor pressure causes the air cushion to expand, and then these liquids like ethanol or acetone are forced out of the pipette tip and drip. Since this type of pipette is sensitive to physical changes to its air cushion, it should be used for aqueous liquids and come in buffers. For other liquids, air cushion pipettes should be adjusted accordingly. Look here for pipettes that support this adjustment. There are mechanical pipettes that can be temporarily adjusted to specific liquids with a small tool. Or there are also electronic pipettes out there where programs make the temporary adjustment quite easy or much easier, and often allow a quite quick and easy change between different liquid types without the need for any calibration. But please keep in mind here that manual adjustment turns the air cushion pipette into a fixed one. So this should then be just used for this specific type you have adjusted to. And please keep in mind that this only reduces the errors and not eliminates them. Another webinar of this series will focus completely on pipetting difficult liquids. So let us take a closer look at the pipetting methods that can be used with air cushion pipettes. It can be used for both forward and reverse pipetting. Forward pipetting is the classical pipetting method that we all know and use every day in the lab. Air cushion pipettes are built for this pipetting and aqueous solutions, and buffers should be pipetted in this way. Reverse pipetting is more or less a workaround for pipetting difficult liquids that differ from water in their physical properties. Consider here, for example, viscous liquids such as glycerol. With reverse pipetting, a bit more of the liquid is taken up and a residue remains in the tip after dispensing. So let's take a short look at both pipetting techniques in action.
Now watch the pipette tip on the left as I move the button on the right. With forward pipetting, press the operating button to the first stop. Immerse the tip and move the operating button up to the rest position. Dispense the liquid by pushing the operating button down to the second stop. Reverse pipetting works better for certain liquids and pipetting challenges. Push the operating button down to the second stop. Immerse the tip and move the operating button all the way up. Dispense the liquid by pushing the operating button down to the first stop. Some liquid will remain in the tip. You can discard it or return it to the aspirating vessel.
So reverse pipetting is thus a method to pipette difficult liquids slightly better with an air cushion pipette, but in general, a positive displacement system should be preferred for these types of liquids. Air cushion pipettes are intended for forward pipetting, and the measurement deviations specified by the manufacturer for these pipettes refer exclusively to the pipetting principle with water. So you can usually check these deviations in the operating manual of the pipettes. However, they are only valid with the correct pipetting technique. So this includes various points like listed here, the size of the air cushion, how I hold the pipette when pipetting, how deep I immerse the pipette tip in the liquid when aspirating, if I pre-wet the pipette tip, and how fast I aspirate the liquid. So these are all aspects that we do automatically when we are pipetting, but the question is, are we doing them correctly? And that's it, what we want to look at closer, mentioned, and the impact they can have on the pipetting result. Let us first have a look to select the most suitable pipette size. In the example here on the left, 10 microliter should be pipetted with an air cushion pipette. The diagram shows the systematic error of the pipettes used for the pipetted volume in percent. So the systematic error describes the accuracy of the device. In addition to a pipette with a nominal volume of 10 microliter, pipettes with 20 and 100 microliter nominal volumes are also used. And the nominal volume describes the maximum volume that can be pipetted with the respective pipette. So just take a brief look at your pipettes in the lab. It is usually indicated on the pipettes, so the nominal volume can be quite easily identified. The pipette with a nominal volume of 10 microliter has the smallest systematic error we can see here in the diagram. So in other words, the target volume of 10 microliter is pipetted most accurately with this pipette. The larger the nominal volume of the pipette, the larger the air cushion, and the systematic error increases with the air cushion size. Therefore, the closer the aspirated volume is to the nominal volume, the more accurate the dosing is. Thus, it is recommended to choose a pipette with the smallest possible air cushion. Let us look at the holding angle. You may have come across the tip on the internet to hold the pipette at an angle during liquid aspiration. Here, an angle of up to 20% is often recommended, but the question is why. If we take up 8 samples of a liquid with different holding angles, as seen here, we actually get 8 different pipetting results. Because the more you tilt the pipette, the more variations you will see in the series of samples, since the hydrostatic pressure in the tip changes with the angle. The more you tilt the pipette, the more liquid you will aspirate. And it is difficult to control the effect because the variations are too small to see them with the bare eye. So for best results, just keep the pipette as vertical as possible. Here we see what impact it has when the liquid is aspirated at a pipetting angle of 45 degrees. 1000 microliter should be pipetted, which is indicated by the purple line here. If the pipette is held vertically during liquid aspiration, between 999 and 1000 microliter will be pipetted, indicated by the blue line. If, on the other hand, the pipette is held at an angle of 45 degrees during aspiration, we can see by the green line that more liquid is aspirated each time. The volume ranges from 1004 to 1007 microliter, and due to the lower hydrostatic pressure, more water is aspirated. So if the pipette is held vertically, we always pipette almost exactly 1000 microliter of water. And by the way, this also applies to multi-channel pipettes. Hold the pipette as vertical as possible during the immersion to get optimal and reproducible results. In addition to the pipetting angle, it is important to pay attention to the immersion depths. The ISO 8655 actually specifies certain immersion depths for different volumes. The right immersion depth depends on the volume you are working with. We can see the specification in the table on the right. However, I think everybody will start laughing at us when we are having a ruler next to our tube and pipette tip in order to ensure the immersion depths. So therefore, try the following. In general, you should immerse as little as possible to prevent the transfer of the liquid to the outside of your pipette tip. However, you have to immerse deep enough to avoid taking up air instead of liquid. Now we move on to a very important but often overlooked aspect of pipetting, the pre-wetting of the pipetting tips. Let's take a look at some pipetting data. 100 microliter of water should be pipetted, represented by the purple line. The blue line shows the results of 10 pipetting steps without changing the tip. A mechanical 1000 microliter air cushion pipette was used. After 3 to 4 pipetting steps, the pipetted volume is close to 100 microliter for all subsequent steps. So the first pipetting steps can be considered as pre-wetting steps, so that the subsequent steps were pipetted more accurately. The effect is even stronger with, for example, volatile liquids, which are different from water. Just try it out, for example, with ethanol in the lab. Pre-wet your pipette tip 3 times and then pipette the desired volume. You will see that the tip drips less or not at all. So to be precise, this is not just pre-wetting the inner surface of the tip, but also pre-saturating the air cushion in the tip or in the pipette. If we do the same experiment with a pipette with a nominal volume of 100 microliter, we see that already after 2 pipetting steps, the pipetted volume for all following steps is close to 100 microliter. So here we also see the effect of the air cushion size, which you have just discussed. This is smaller in this case because the pipette was used with a nominal volume close to the volume we wanted to pipette, 100 microliters. And a smaller air cushion requires fewer pipetting steps to pre-saturate the air cushion. So to increase reproducibility, pre-saturate the air cushion by pipetting the liquid up and down, maybe about 3 times. But depending on the liquid type and volume, more pre-wetting steps might be helpful. By the way, this problem does not exist when you're using a positive displacement system because, probably you remember, no air cushion, no problem. During pipetting, the speed at which the liquid is aspirated and dispensed again also plays a major role. Here, working slowly pays off in 2 ways. First, slowly pipetting reduces the formation of aerosols and thus the risk of contamination. Contamination can occur with any liquid movement, so through direct liquid transfers because of splashing or when we are touching the vessel wall, but also through aerosols, which can transport contaminating or even infectious particles. These particles are then drawn into the pipette cone during the pipetting process and settle there. During the next dosing, they can be mobilized again and distributed through the airflow. On the other hand, slow pipetting also reduces the shear forces that act on the liquid at the tip opening. So thus, also on the containing functional units when you think about proteins, DNA, or even cells. So therefore, pipette slowly and smoothly to minimize aerosol formation and also shear forces. Filter tips protect very well against aerosols and should be considered when using air cushion pipettes. And also an electronic pipette can guarantee slow and very smooth pipetting steps because I have defined piston movements. So now we have heard a lot about what we should consider when aspirating liquid with an air cushion pipette. You might think, oh, that's really complex, but it's not. Here are just the important points in short. So when selecting the pipette, consider the size of the air cushion and choose the pipette with the nominal volume closest to the volume to be pipetted. Observe a small immersion depth of the tip into the liquid and hold the pipette vertically during a liquid aspiration. Pre-saturate the air cushion by pipetting the liquid up and down several times. Generally, pipette rather slowly and smoothly, and wait a moment until you remove the tip from the liquid and carefully wipe it against the vessel wall. That's it. And by the way, pipetting errors add up. Here's one example of the effects of a wrong pipetting angle, the incorrect pre-wetting, and incorrect wiping of the tip, and temperature differences between the pipette tip and the liquid. So the ISO 8655 describes the effects of the different factors, and I don't want to go into detail here, but the example here makes it quite clear that instead of the targeted 1000 microliter volume, 70 microliter less are pipetted due to the errors during pipetting. So depending on the experiment, this may certainly have an effect on the overall result. And what about dispensing? So here we can relax for the most part. So ideally, dispense the liquid against the vessel wall. If you are pipetting smaller volumes, dispense them directly into the liquid if possible. So as long as there is already some liquid in the vessel. So now we know what we should pay particular attention to when pipetting with an air cushion pipette. Now let's take a closer look at what to look for when choosing a pipette tip. Those of you who have already attended our last webinar may remember this slide. Here I briefly explained how important it is to choose a good pipette tip because pipette and tip are to be considered as a system. Pipettes are adjusted to the tips, which means that the measurement deviations for the systematic and random errors that manufacturers specify for their pipette tips are valid for this combination. If the pipette is used with alternative tips, these deviations can be quite different and even worse. For further information, please refer to our application note, The Tip of the Iceberg. So if you use alternative tips, you usually make sure that they fit on the cone. If this is the case, it is often automatically assumed that the pipetting results are also correct. But unfortunately, this is not always the case, because even if the tips visually fit to the cone of your pipette, this does not allow any statement about tightness and or performance. The most important influencing factors on pipetting results are tip design, quality of orifice, tip fit, and tip change. There exist more influencing factors being less important. However, you can break down into two categories. We can see them here: design and shape, and quality. I have one good news, that design and shape-related influencing factors can be adjusted. The bad news is that the quality-related influencing factors cannot become adjusted. Here we can see some examples for poor quality tips regarding the tip opening compared to the Eppendorf standard tip of 10 microliter. So this zone where the liquid leaves the tip during dispensing is very important for the accuracy of the results. At this part of the tip, the drop cut off occurs, and any imperfection of the geometry or shape, for example by production failures, leads to water retention. This especially plays a role with small volumes. A poor drop cut-off may not only impair the pipetting result, but can also make it impossible to dispense small volumes. Sometimes a drop leaves the tip, sometimes it doesn't. In general, tip-related influencing factors are like an iceberg. You can see some of them, while other effects are more or less below the surface and are not easily recognized. You can see only more or less 20% with the bare eye. Tips that fall off or fall down are just one example and very easy to see. It may also be possible to see with the bare eye if tips are bent. It is also not uncommon for poorly fitting tips to cause liquid to splash into the cone of the pipettes. But the other 80% stay undetected if the pipette and tip system is not properly aligned. Some points are listed here, and an example is tip design-related influences on the air cushion size or leachability, so not detectable, but can have negative effect on the reproducibility of our data. So if using alternative tips, keep in mind that a tip fitting onto the pipetting on the pipette cone does not say anything about the system's performance. But how to choose the best tip for an air cushion pipette? First of all, if possible, follow the ISO 8655 requirement and understand the pipette and its tip as a system. Therefore, prefer the pipette and tip from the same manufacturer, and I have already mentioned the ISO 8655 several times in today's webinar. In our last webinar of this series, we will deal with this standard in more detail, and let me just point out the following today. So this standard defines the internationally accepted reference methods for manufacturing, operation, and calibration of volumetric instruments. So if you send your pipettes to Eppendorf service for calibration maintenance, for example, the instruments will be calibrated according to this standard, meaning according to the methods and values stated in this ISO. This summer, a revised version was published online by the ISO Council, so calibration labs will change their working standards accordingly. Eppendorf is also working on the adaptation and will adjust its service in the upcoming month. Calibration labs are currently in a transition phase from the previous to the new ISO 8655 version, which comprises a total of 9 chapters as of today. And part 2 deals extensively with air cushion pipettes. However, pipette tips are also so important that also the new ISO 8655 standard describes pipette and tip to be a system. The error values are only valid for this system. This means if users apply a different pipette tip than the recommended one, they break the system. And this may have severe consequences on the data reproducibility. So system manufacturers like Eppendorf also sell some kind of security that the components of his system are of a design and quality which enables the system to perform within specified error tolerances, regardless of the tip batch. So if you decide to use alternative tips, check them very carefully in advance. Take a look at the tips of different batches. That is very important. And if possible, also using a microscope. This will provide you with a first impression of the quality and look very critical at the liquid flow during pipetting. Is it calm or disturbed? Does the liquid splash into the cone? If you have the possibility in-house, calibrate the system with and without tip change and look, are the pipetting results the same? Also look at the specification and certificates of the tips. They provide very important information about the quality control, the steps during the production, or possible leachables that can interfere with your assays. Although the updated ISO 8655 now requires the tip manufacturers to prove that their tips meet the system requirement, take a critical look at the tips. Also, don't forget to mention the tip type and update your SOPs, protocols, or even publication in progress to know that pipette and tip are used as a system. So when selecting pipetting tips for air cushion pipettes, you are often faced with a difficult choice. There are different tips without and with a filter in different purities and then also in different packaging units. Usually the packaging unit will be determined by the purity you need for your experiment. So take a look at what you need to use for the pipette tips for. If they are for a routine application that require clean but not sterile tips, bulk tips will certainly be sufficient. If you are using the tips for bacterial culture, cell culture work, or even RNA and DNA analysis, there will be different requirements for tip purity. Here, look at what can interfere with your experiment, such as residues of human or bacterial DNA, enzymes such as DNAs or RNAs, leachables, or even endotoxins. Accordingly, tips are available in different purities, and for further information, please refer to the Eppendorf Purity Selection Guide. The higher the purity, the smaller the available packaging unit, from bulk to boxes with reloads, racks, but also single blistered tips. So with this webinar, we wanted to point out certain aspects to be aware of when using air cushion pipettes. Due to the functional principle, these are ideal for transferring aqueous liquids in common buffers. Moreover, they are designed for forward pipetting, reverse pipetting, in which slightly more liquid is taken up than later dispensed, is more or less a workaround for pipetting difficult liquids. In this case, a positive displacement system should be preferred. The correct pipetting technique contributes significantly to reproducible data. So when aspirating liquid, pay particular attention to the size of the air cushion, pipetting angle, immersion depth, pre-saturation of the air cushion, and slow speed. When dispensing the liquid, you should perform a wall dispensing, and for smaller volumes, it is better to dispense directly into the liquid if possible. And finally, the choice of pipette tip is as important as the choice of pipette. A pipette is just as good as its tip. Although being single-use items, tips can impair your pipetting results, and the ISO 8655 defines the pipette and tip build a system that, so thus it is recommended to purchase both from the same manufacturer and determine what purity of tip is required for your application to collect reliable data. If you need to use alternative tips, think of the iceberg. And with this, I'm at the end of our presentation. So far, thanks for your attention. And I would like to hand over to Simon again for our Q&A.
Thank you very much, Nadine. We indeed got a few questions via the chat tool. Let me quickly go through. So basically, we have a question regarding the lifetime of mechanical pipettes. So the question is, what is the lifetime of a mechanical pipette, and does the efficiency of air cushion pipettes reduce over time?
Okay, so in general, you can say that the lifetime is as long as you keep the pipette maintained. So manufacturers of pipettes provide a certain guarantee period, let's put it like this, but it is not meant as an end date. So there's no official end date, let's put it like this. So it's very important to maintain your pipettes and to clean it. So with this, you should look at cleaning and maintaining especially when you're working with aggressive chemicals. So when you're working more with water, it's a purpose for, or it's the intended use primarily for air cushion pipettes. But as I mentioned already during the webinar, aggressive chemicals is not the purpose. The first use of air cushion pipettes, and they can harm, let's say it like this, the air cushion pipette. So here it is really recommended to clean and also calibrate the air cushion pipette more than once a year, as it is stated in the ISO. So the next point which you have to consider during the lifetime of a mechanic pipette is the frequency of use. So how heavily is a pipette used? How many different persons are using the pipette? So we have heard a lot of the pipetting technique. However, every person is pipetting a little bit different. So just have a look. So on frequency, what kind of pipettes you use, take care of your, and clean your pipette, maintain it, take care of calibration, and then you will have a quite long time together with your pipette.
Thank you. The next question I would like to ask you is, you explained forward and reverse pipetting with a standard 2-button pipette, but what about 1-button pipettes? Probably they use a reference pipette. Which one is better, 1-button or 2-button pipettes?
Okay. So yeah, in the video, it was explained with a 2-button pipette. That's right. But when you compare, the performance of a 1 or 2-button pipette is not different from each other. So I think the use of a 1-button or 2-button pipette is actually personal preference, I would say. So what you may want to consider when choosing the pipette is that a 1-button pipette comes with a lower risk of contamination. So here, think about the aerosols, which we also have covered in this webinar. So when using a 2-button pipette, you have to aspirate and dispense the liquid with 1 button. So during aspiration, aerosols of the liquid can get into the pipette tip and even higher into the pipette cone. And then the liquid is dispensed and you aspirate air again when releasing the operation button. So thereby you may aspirate the aerosols again before you switch to the second button and eject the tip. When you now think about a 1-button pipette, with this one you aspirate and dispense the liquid and then eject the tip in the same downwards movement. So you do not aspirate the aerosols back into your pipette, leading probably to a lower risk of contamination. So regarding the performance, both devices are the same. Regarding contamination prevention, it can be considered to differ between those both devices.
Okay. Then we have a question about a liquid type. So the question is, what should I do when viscous liquid sticks to the outside of the pipette tip while aspirating?
Yeah, viscous liquids are quite challenging, especially like glycerol and something. So first of all, when you are using an air cushion pipette with viscous liquids, take a closer look at the immersion depth. So especially when pipetting viscous liquids, many persons make something like a deep dive into the liquid. But as I also mentioned, the ISO says that you should adapt the immersion depths. However, it's quite difficult. So just check to immerse the tip as little as possible without taking up air. And maybe related to this, I can add something based on a question we often receive here in related to this question, that if I can use air cushion pipettes then just for aqueous liquids. And here I would put it differently. So air cushion pipettes are primarily suitable for aqueous liquids due to their functional principle, the air cushion. When you think about the chemical resistance of pipettes and tips, and here I refer to the Eppendorf products. air cushion pipettes can also be used for many difficult liquids, which differ from water. And so here it's important to check the chemical resistance lists for the devices. However, it's just important that we as a user are aware that the pipetting results with an air cushion pipette for liquids other than water are not as accurate and as precise, and the measurement deviations are different from those from water. So you have heard that you can minimize the error, but in general you can pipette it with the air cushion pipettes. However, the error is bigger than with water. And because this is a very big topic, put it like this, we will also dedicate one complete episode to this topic during this series. So maybe watch out also for this episode.
Okay. Looking at the questions, I think we have another question which I am pretty sure that you can answer with your experience in cell culture applications. Do we have any advice on how we tackle or how they can tackle contaminations in cell culture? Does anything help other than sterile tips?
So contamination in cell culture can have many different causes. So, and there are also very different types of contamination. I'm unfortunately don't know exactly what kind of contamination you are struggling with in detail. But when we think of transferring liquids, I think different points make sense here. So in any case, use sterile tips, but I understand from your question that you're already doing that. You could also think about filter tips, because in cell culture, it's mainly the aerosols that transfer contamination during pipetting. You can also think or consider a positive displacement system, because here the sample is hermetically sealed and you are not dealing with any kind of aerosols within the system. But here the tips are relatively expensive, so that maybe it's not the best option for you because of the throughput that is required in cell culture. And so as I said, that there are different types of contamination and also causes for it in cell culture. So here, for more information, maybe you can take a look at our webinars that Eppendorf offers. And I think there's also something regarding contamination prevention. So maybe you can also have a look here for further techniques to prevent or to at least reduce the risk of contamination in cell culture.
Okay, we have a few more questions. I'm trying to pick one or two other ones with the time left. So we have one question I see, which is, as I understand it, regarding the storage of pipettes. So the question is, when you put a pipette away, should it be put to the volume in lower range or higher range, or I guess that's the nominal volume then. And the question is if it affects the spring tension in any way if we keep it in the lower range somehow.
A very interesting question. Thank you for this, because this is a question we received during the last months quite often. And you can leave the volume as it is. When you're finished with your pipetting steps, you can leave the volume as it is and can store it. So there's no need to store pipette at their nominal volume. So with the highest volume of the pipette, which to pipette. Quite easy. Just let it like it is.
Okay. Yeah. Looking at the time, I suggest we wrap up our round of questions and answers now. But we will take another look in the chat and probably also reach out to you individually if we find open questions that we can answer. Thank you, Nadine. It was a great presentation and also great round of answers of questions answered. Thanks.
Thank you, Simon, and for moderation, and also thank you, guys, for attending this webinar. See you next time.
Yeah, thanks everybody for joining. I just wanted to highlight again that we're doing a full series of free pipetting webinars, and the next episode in this series will focus on electronic pipetting, and it will be streamed live on Tuesday, September 27th. Goodbye, and see you next time in the Eppendorf Lab channel.